Today we'll be continuing from where we left off last week, right? But before that, let us just go through some recap, right? So in the beginning, we started with a basic circuit whereby we were just using a push button to actuate our cylinder, right? Our cylinder, it was a spring, it was having a spring, so that cylinder retracts automatically, right? Once you remove your hand from the push button or your finger from the push button, right? So that is how the pneumatic circuit looks like, and that is how your electrical circuit looks like. I know we are using PLCs, but this is just to give you an overview of what we did, right? So if you can remember during your electro pneumatics last term, this is the kind of circuit we're building. So a circuit that resembles, so on the right, this circuit resembles to this one on this next slide. So this one that we have here resembles this one on the right, this circuit, right? And this one, it's a electrical pneumatic circuit with a PLC, right? So as usual, you will have your pneumatic circuit on the left there. And then, okay, let me just go to presentation mode. Okay, so this is the electrical pneumatic circuit with PLC. So on the right, where you have your fluid sim out, fluid sim in, that's your PLC section, right? The only difference with this circuit compared to this one in the previous slide is that instead of having one push button, you have a push button, you have a stop button, and you have an emergency stop button, right? And the other thing you can observe is with your stop buttons and your emergency stop buttons, they are normally closed, right? So yeah, and then you have one output, right? So that one output just means that in this circuit, we were just sending a signal to one actuation side, right? That is Q0, right? So we're having one solenoid, right? And then, so that's how your emergency stop button looks like, right? For those that haven't seen one. And then we started off by putting these variables. So in the beginning, I put on all of the variables, but yeah, I realized I should have just started with these ones first, but it's not a train smash, right? So these inputs, these inputs and outputs are for your basic circuit. So you'll have your you'll have your start button, stop button, emergency stop, and your output, right? Then you have this kind of a circuit. So if you can remember, initially we built this kind of a circuit on our codices, right? So this code below is for testing, right? This is a typical code that serves no purpose in PLCs. It is used for testing purposes. So during your test, if you want to test if like there's communication between your codices, your PLC, you just use what you call, you just use this code to test, right? If it's working on your fluid sim. I can't see. Okay, the people are saying they can't see my screen. Let me just share again. I forgot to share that. Share. Okay, guys, I believe now you can see everything that we're doing, right? So I'm just going through a presentation, just giving a brief recap on what we have done thus far, right? Okay, so I'm just going to go to presentation mode again. So as I was saying, this is the basic circuit we had built initially, right, for just testing purposes. And then we then went on to build on the basic circuit by introducing what? By introducing a stop button and an emergency stop button, right? And then with our output, or Q0 there, right? Now, in this circuit, what we did in the last session is we were now latching our circuit. That is to say, we wanted our cylinder to remain in the advanced position up until we retracted that cylinder by pressing a stop button, right? And then the other thing we should take note of is that your inputs, they are normally your I1, I2, they're normally closed, right? And your I0 is normally opened. But immediately you press your I0, your start button, it closes the contact and then allows for current to flow through the circuit and passing through to your stop buttons and thus to your Q0, right? Now, that if you can observe that Q0, that is our output. When we were latching, if we wanted to continue providing electrical current to that Q0, we needed to latch it. How you latch it is by assigning that output to a contact, right? And then also naming it the same as your output, right? And then connecting it parallel with your start button, right? So that's how we were able to latch your circuit, right? Then, as I said, you break your circuit either with a stop button or your emergency stop button, right? And then here we have a 5-way single solenoid valve, okay, with a spring. Okay, we covered that. Okay, so today we're gonna just be building on that. So in a sense that we'll be using a 5-way solenoid valve and connecting it to a double acting cylinder, right? Okay, so, and just something that we have to fix is that with your, if you can observe I1 and I2, the stop buttons, they are normally closed, but there's a difference. I don't know if you can observe the symbol difference. With the emergency stop button, you are having a sort of a spike. And then with your stop button, it's a kind of a T. It's like a, should I say, an inverted E or a T symbol, right? So you have to make sure that always your emergency stop button, its symbol is like that, and the stop button is like that, right? Because it's easy. The mistake I made was having two of these stop buttons, right? Yes, they were performing the function that it was meant to perform, but it was not the correct stop buttons. Right? So we're just gonna also correct that, right? And then just note that this 5-way valve is a non-latching, right? By that is that you'll see that once we compress our push button, it will go forward, and then you'll need to press your stop button so that the cylinder goes back, right? Oh, actually, no, actually I'm wrong. So because we're using a 5-way solenoid valve with a spring return, this means that once we press our push button, if the cylinder will advance, and then it will come back automatically, right? You will need to add sensors in the circuit in the future, right? So just take note of that. Right? So for now, let us just build this circuit and program this circuit, right? Okay. So this means that we're just gonna amend a few things here, right? Just gonna put on a So in this exercise, we're just going to use a double acting cylinder. And then instead of a 3-way valve solenoid, we're gonna put on a 5-2-way valve solenoid, right? So we'll go to frequently used wave valves. Under the solenoid operated group, you'll select the fourth one that you see there. And then we'll put it there on our workspace, right? Okay, let me just check something. Okay, so we're just gonna only control the advancement of the cylinder going forward, right? Okay, and then we have this one. Okay, so remember I said we should fix our stop buttons. So this is fine. Then we just have to fix our stop button. So if you go to switches under manually operated, it's the third option there. Push button brake. So you'll appreciate that they are not the same, right? Although they serve the same process. Okay. Oh yes, I'll actually show you why they're actually different in a way. I'll actually show you why they're different, right? So just make sure you have that circuit on. Then we're gonna move on to so if you know you're kind of a bit on the slow side, just take a picture, and then so that when we continue, we do not really get left behind that much. So another thing I forgot is on your valve solenoid, if you defined it as Q0, also on this actuation side of your 5-2-way valve solenoid, you have to also assign it the same label, right? So it's going to be Q0. Right? So just make sure you have those two communicating like that. Okay. So what should happen in this exercise is once you press our push button, the cylinder should advance and then it should come back automatically, right? Once you have released our finger from the push button. Okay, so once you're done with that, I'm gonna carry on to the to the program here, right? Okay. Okay, so on our program here, we have your I0, which is a start button, and then we have I1, which is a stop button. We have I2, which is a stop button, and then we have Q0, right? So yes. Okay, so yes. Okay, thanks for that. Yeah, guys, just get in the habit of naming your variables, right? You can say stop button, SB. Okay, stop button. Thanks for that. Okay, so now we have to build a ladder logic code that is that resembles what we did here, right? Now, one thing that you should take into consideration to make your life easy in understanding this is before current can go to your output, you have to make sure that all your contacts in series, they are in a true state, meaning that they are allowing current to pass through, right? So just keep that in mind, right? You'll see exactly what I'm talking about as we continue, right? So we have your input, your start button, your stop button, and your emergency stop, right? All of these, they will take part in controlling our, okay, they won't take part, in controlling our output. It's only the start button, right? So once we press our start button, the cylinder will go forward and then it will come back, right? So we can now build. So we have latched the circuit. This is to allow for a current to get to the cylinder, right? And then let us just build our circuit. So how you build is you go to symbol configuration and then you build. Huh? Is it cold? I don't have the remote, guys. I don't have the remote. Can I borrow my jacket? Okay, can continue. Okay, guys. Leave the poor child, okay? Leave the poor child alone. You're jealous. You're jealous. You're jealous. Okay, guys. Let us continue. So yeah, just a quick recap on your settings. Just make sure that you enable direct I/O access. But yeah, normally if you save your file, all of these things they will be saved, right? So we're just now gonna go ahead and log in, and then just gonna press yes. If you see this pop up, you're just gonna press yes, and then okay. So as you can see, okay, I'm just gonna press play. So you'll appreciate that there's a blue line, right? That blue line we can set our current, and it is unable to pass through only and only because the I/O is normally open, right? So it cannot allow the current to pass through, right? So anyway, after that, you must make sure that you press play, and then we're gonna split our screen here. So that we can see what's happening on the PLC, on the fluid sim side. Okay. Okay. So let me just press play this side. Okay. So one thing you can observe, as I said, for your Q0 to get output, your contacts must be in series and they must be in a true state, right? So if you can observe I1 and I2, the state is what? There's a table there up there. The state says true. So meaning those contacts, they are ready to perform their function, but current cannot flow yet because your I0 is still normally open, right? So for current to pass through, that's when we have to press our push button, right? So we're gonna go ahead and press our push button. Okay. Remember we said that the cylinder should come back automatically. The reason is that we latched. So let's just delete that. Just delete that latch there, and let us just simulate again. Okay, so just download again, and then press play. Okay, so if we press play, before that, let me just check your easy port here. So most of the time when you start running a simulation, your easy OPC version 5.7 will appear. So just make sure it's on the correct configuration, right? Just make sure you are connected to localhost, right? If you're not, you're gonna have trouble with running a simulation. Okay, so just gonna run that. So if you can observe that the cylinder goes forward, and then once we release our finger, the cylinder goes back. So I'm just gonna run that again. Once you press the push button, the cylinder goes forward, and then once you release, the cylinder goes back. Okay, so now I'm just gonna go to our slide so that we can go to the next exercise, right? So remember, we're always building on our previous circuit, right? Okay, so after this, so we're done with this exercise, right? So after this, I'll upload this slide for you once you're done with the lab sessions, right? So these are the types of sensors, and as I mentioned previously, as we are concerned with using magnetic proximity sensors, right? You can go ahead and check out how optical proximity sensors work and other sensors. But I'm sure you are aware of the other ones because of the exposure due to your Arduino project, right? So I'm just gonna go next. So in this one, in this exercise, okay, in this slide, this was the pneumatic and the electrical circuit, right? So in this circuit, please pay attention here. So we'll be relating this electrical circuit to the PLC circuit, right? So if you can, and it's also a refresher anyway. So if you can recall last term, we had this kind of, we had these two circuits, your pneumatic circuit and your electrical circuit. So in this circuit, what happens is once you press your push button, your cylinder will extend, and once it reaches the center here, it will go back, right? It will go back to its initial position, right? And we remember we're using relays, so this was for indirect actuation, right? And then we're using also our solenoids to communicate with our 5-2-way valve solenoids, right? Then on the PLC side, this is what you have, right? On the PLC side, you have something similar, right? But obviously here we're not using relays, right? We're just using these two modules, right? Fluid sim in and fluid sim out, right? So we're just now gonna build this circuit, and then we're gonna build the ladder logic diagram that is relates to this circuit. So I'm just gonna give you 2 minutes to modify your current circuit and add your sensor I3, and then also add your Q1, right? So we are adding Q1 because now we're using a 5-2-way valve solenoid with two actuation sides, right? We have to actuate the left actuation side of your valve solenoid and your right actuation side of your valve solenoid. So you must be having Q0 on Q1 and I3 on your circuit. So yeah, I'm just gonna give you 2 minutes, or as I'm building, you also have to build, right? Okay. So I'm just gonna exit simulation mode here. And also I'm gonna exit simulation mode here. So I'm gonna stop and log out here. So we're gonna come back to this one and build this one. Okay, so here we add our changeover, right? So for your sensor, you add a changeover. Okay, and your distance rule, right? So your distance rule, you'll find it under actuators, right? And because we're just having, so we're having a sensor in the advanced position, right? So keep that in mind. We're not having a sensor in the near end position, right? So we're going to have sensor 1. We can just call this sensor 1, and then it begins at 100 and ends at 100, right? And then you're going to click OK. Then we're going to go to our changeover. So under switches, under electrical controls. Okay, let me just expand this. So under general switches, so switches, general switches, then you change over there. Okay, so we're gonna connect this one to I3, right? Okay. And then you can call this I3 or sensor 0. Yes. Huh? Sorry? Oh yes, S1. S1. You're right, because there won't be communication between the two, right? Okay. Okay, and then we're gonna add another valve solenoid. Then you're gonna call this Q1. Then okay. So make sure you connect to the correct ports, right? So Q1 is connected to port 1 there. Okay, and then I'm just gonna press play, right, and see something. Okay. So one thing that we should observe. Okay, so remember I said our I1 will be responsible for breaking our circuit, right? Yes. What's up? Sorry? Oh, okay. Thank you. Thank you. I'm glad everyone is awake. Thank you for that. Okay. Okay, so we're gonna control both sides, right? So we're gonna control the advancement, the rate at which our cylinder advances and the rate at which the cylinder retracts, right? So under shut-off valves, you'll have another flow valve, one-way flow control valve. Okay. Hey, man. We don't have chalk. Do you see chalk? Yeah. I know. I know, you can take. No problem. Okay, so we're gonna also control the flow, this side. Right, okay, then I'm just gonna press play. So one thing you should observe is that your S1, it's not on, right? It's off, right? So we're going to introduce a concept called negation, right? So remember I said that for your output to receive the current, you have to, your circuit has to be, all the contacts on your circuit, their states should be true, right? All of them should be true. So negation, what negation means is that you're changing the state of your circuit, right? From off to on, right? So so let us do that on our circuit there. Now we also want to latch our circuit. Right now we no longer have what's this? So we're going to also latch our circuit so that it is only broken by sensor 1, right? Meaning that it will only retract when the cylinder reaches sensor 1, right? So I'm gonna introduce the latch there. Okay, so I'm gonna latch first. So we're gonna insert a contact below, and then we're gonna also have what you call, we're gonna have another contact here. So this one, it's our sensor 1, S1, right? Now remember what I said. The state that side is saying it's normally open, right? There's no flow of current, so we have to negate, right? So that we change the state of that contact, right? Of that contact. So you're gonna click on negation there at the bottom, right? You're gonna select negation, and then you should see those two parallel lines with like a diagonal line in between, right? And then now the other addition we're gonna add is your Q1, right? And also, if you can observe your Q1, how can I put it? Your Q1 is off as well, right? So we also have to negate that Q1, right? And change its state in this regard, right? Yes. How do you open the file? Which file? Yeah, this is okay. They're coming to assist you. Okay, so we're gonna have a contact, right? So you're gonna have another output. So you're gonna click on that Control Z. So you're gonna click on that Q0, and then you're gonna say insert coil. Okay, I inserted the wrong one. Okay. So right click and then insert coil. So you have insert coil, insert set coil, and then insert reset coil. As we're using insert coil, right? So you will see another coil there connected, right? And then this will be our Q1, right? But we have to also negate this, right? And then because initially it's off, it's not on, so we're gonna negate this, right? So once you're done with that, we are done with our second, right? So what should happen is once we press our push button, our cylinder will advance, and once it reaches center 1, it will go back to its initial position, right? Yeah. Right, so let us just first log in. Oh, before that, always just build your circuit, right? And then go back to your PLC program, and then go to login, right? And then log in with online change, and then click OK. And then you're gonna click start, right? So you'll observe something, right? You'll observe that all of your contacts in series, their state is true, meaning you can see the blue color, meaning current can pass through there, right? Now, the Q0, it will not extend up until we press our start button, right? And then our Q0, once the cylinder reaches your center 1, your Q0 will be off, and then what will now turn on will be your Q1, right? And then let us just put that into practice. Okay. Okay, so as we are running, just keep on observing your PLC and your pneumatic side, right? So before we start the push button, I clicked on start button, right? So what will happen is, remember we changed the state, right? Hence you see current flowing through Q1. But once you press stop button or start button, that current will be transferred to your Q0, I mean from Q1 to Q0, and then allowing the cylinder to go forward, right? So let us just press start there. Yes. Okay, our cylinder is not coming back, right? So your sensor one is not off. I mean, it's not allowing the cylinder to go back. So let us investigate what happened. Okay. Okay, let us see something. Yes. Saying not defined. That might be something. Let me just stop this. Can you check on your code, on your inputs here? Is it okay now? Okay, let me just check my preparation for something I missed. Okay, so this is the answer here. So as you can see, we followed everything accordingly. Let me see. I3. Okay. Okay, let us just check something out. So, okay, let me just try troubleshooting to see if it's something. Okay, let me just check. S0, I1. It's
S1, Jonah I3. S1, like go to S0.
This one?
S0, no, S0 top there.
Oh, okay.
Change that to be S1.
Oh, okay.
And then the other one will be S2. Yeah.
Right, thanks.
Yeah.
Okay. All right.
But you guys said you mustn't supposed to use S0 again. You said you must use S1. So that's the S1.
Okay. So if we can press play. Okay, if you can press play, and so yeah, if you press play, you'll see that once you press play, the cylinder will advance, and then once it reaches the sensor will break the latch, and hence retract the cylinder, right? So I'm just gonna do it again. Okay. So if you can observe, once you press the start button, the sensor one momentarily switches on and then it switches off, right? and then goes back, right? Okay, so now we're just gonna introduce another thing on top of this, right? Okay, so I'm just gonna go out of simulation mode, and then I'm gonna go back to I'm gonna log out, and then I'm gonna go to the also stop simulation this side. Okay, so going back to the slide. So on this slide, again, we are showing the pneumatic circuit and the electrical circuit. And now we'll be introducing a second sensor, right? So we'll be introducing a sensor that senses the initial position, right? So on the electrical side, we have a push button. And so this is like what we did last term. So yes. Okay, so we would have a stop button, and a start button and a stop button, right? So what would happen is initially sensor 1 is on and sensor 2 is off, right? And once we press our push button, that's when our cylinder advances, and then once the cylinder reaches sensor 2, that's when sensor 2 breaks that latch and allows the cylinder to retract, right? So yeah, on this electrical circuit, these are your proximity sensors now, right? And then you have your relays, and then you have your valve solenoids, right? Okay, so next. So the PLC circuit that resembles that electrical circuit that we just saw in the previous slide looks like this, right? So this is what we'll be building, and yeah, let's just get to that building. Okay, it's just gonna go to a fluid sim, and then yes. Yeah, sure.
Guys, we all know that it's not possible to close this, again. If you want to close it, should you say, for instance, it's constantly done, it doesn't want to connect. You go to Control Alt Delete, Task Manager, and then it's gonna come here, and then you end it, ne? And then that's how it's gonna disappear. Ne? Most of you find that it constantly doesn't want to connect, so it wants you to shut it down first, and then when it comes back, then it will work. So for practical demonstration, you see now it's gone. Even here on the list it's gone. So let's try to call it stop. Okay. Okay. Obviously, you want us to do this thing again and start. You see, it comes back.
It was recorded. It was recorded. It was recorded. Huh? You'll hear him. You'll hear him. Trust me. Okay. So yeah, I'm just gonna go out of simulation mode, and then I'm gonna delete this sensor, right? And then we're now gonna put on proximity sensors, right? So for your tests as well, be sure that you will have to use proximity sensors, right? Okay, so just gonna go to proximity sensors. So under switches, go to proximity sensors there, and then there you have it's only one object there. So select that magnetic proximity sensor, and then you select another one, right? Okay, so this one we call it S1. No, S. Wait, let me just check if it's the same as. So sensor 0, it's S1. Sensor 2, it's S2 is S1. Okay, it's fine. So this one, the rear end one, is S1, and then the forward, the sensor that senses the advancement is S2. Right? So I'm just gonna be careful now when I'm labeling. So you go to your distance rule, right? When you go to your distance rule, you'll put this one, S1, it's 0 now, 0, 0, beginning at 0 and ending at 0. Then you have S2. So ends at 100, begins at 100, ends at 100. So S1, as I said, senses your rear end position, and S2 senses your advanced position. So you're going to click OK, right? And then let me see. Okay. So please pay attention here as you are connecting these proximity sensors. So we're going to connect this connection there and this connection there. And then we're going to connect this one to the 0 volt line. Students last week, they showed me that you can actually, I was creating another 0 volt line. But yeah, you can do it in both ways. So I'm just going to show both ways. Okay, so you do it this way, rotate 180. Yeah, so this is how I was doing it, connecting this end to this end, and then connecting this end to number 3, and then connecting this end to number 4 here, like that. But apparently you can, instead of doing all of this, you can also connect to this line here, just like that. Just like that. So it's the same thing, right? So yeah. So let me just delete this one. Okay. So this is now us introducing our sensors, right? So sensor 1 initially must be on, and then sensor 2 will be only on when the cylinder advances, and then it will also be responsible for retracting our cylinder, right? Now, if you can press play. So if you can press play, you'll observe something, right? If you look at stop button and your emergency stop button, they are red, meaning they're on. And then meaning on ladder logic, you'll use normally you'll use your normal contacts without negation. And then if you look at your S1 is like in a bold dark red, if I can call it that, right? Meaning it's on, right? But S2, it can be deceiving. You might think it's on, but it's not actually sensed. It's not on. There's no current flowing through it, right? Even though you see this light red color, right? So for S2, we know that in the ladder logic, the state will be what? It will be negated, right? But S1 will not be negated, right? Okay, so we'll now go to our ladder logic and amend accordingly, right? Okay, let me just do this. So remember, S1 is the one that is not amended, that is not negated. So I'm just going to delete that and put it in front of our start button, right? You can put it on this line, but I think it's appropriate to put it next to our stop button because initially, I think it's much more, how can I put it? It makes much more sense, right? Putting it in front of your stop button, right? Because it's your stop button, your sensor, that'll be on, and then that'll allow the cylinder to go forward, right? And then I'm just gonna insert contact, and then we're gonna call that S1, right? Then we're gonna put a contact here that is negated. So a shortcut to that is you click on that line and then you insert negated contact, right? So now this is now bringing shortcuts. So instead of like clicking on a contact and right clicking and clicking negation like this, you can, I'm just gonna fix this. You can just immediately right click and then insert a negated contact, right? So this negated contact will be our S2, right? So So what should happen is once you press our push button, the cylinder will advance and then it will retract automatically. Then before that, I'm just gonna build. So you see why it's important to build. This PLC program is not checked, right? So I'm just gonna check. Okay, I'm just gonna build. Let me build. I'm just gonna check this. So yeah, make sure that all these are checked, and then you build. Okay. I think it's okay. I think it's okay. Although it's giving me an error here. Let me just check something. So I used to. Okay, let us just run and see what's up. Because I can't identify the error. But it's just telling me something about PLC program. It's highlighting our PLC program here. Okay, let me just build again one last time. Why are you giving me errors now? 0 errors, 0 warnings. Okay, we have 0 errors, 0 warnings there, right? So I'm just gonna go to your PLC program, download, then click OK there, and then I'm gonna press play. So as you can see, sensor 2 there, it has a current, it has a blue light there, meaning that its state has been changed and it will now allow our current to flow through, right? Okay. Can I check something? Okay, so let us just yes. Okay, I think it's something that you did, obviously. Maya, can you assist the lady? Okay. Yes. Well, it said 0 warnings on my side, but let me see. It says 8 here. It's going to say 8. Yeah, I can. Let me see. Let me just hover over that. Okay, let me just go out a bit. Okay, so are you getting these errors here, like this? Yeah, 8 warnings. So I'm also getting them, and with regards to my addresses, right? Saying I0.3 is not defined in any device. I'm just gonna check again my devices here. My devices are fine.
That error, you solve it by saving everything and closing and opening the project file.
Okay, thanks for that. So yeah, so how you clear those errors is you save your project and save it into a file that you will be able to retrieve it from. So you're gonna say save as, save to your thought space, then and then click save, right? And then you will close your program, and then we're gonna open it again, right? So go to where you saved it from, and then you're gonna open it again. Okay, so just gonna cancel this. Okay, and then you'll see your program there. And then you're gonna just try to build. So on simple configuration, You're gonna click build. Are you guys still having the same error messages after opening it? No. So it's only me. Okay, let me just log out. Oh, okay. So when you log in with download and press play, you won't see those errors. Let me just. Okay, yeah, I also have those errors. Okay, let me just try saving it again.
Wait, you scroll down on your variables.
Okay.
Okay. Click on the plus sign. Click on the plus sign. Go down. Click on that one. Yeah. Then play it again. And then download.
Okay.
Press play.
Okay.
Press start.
So if you press start, so it's working. So ladies and gentlemen, so once you press start, you observe that your cylinder advances. Then once the sensor 2 is on, it'll retract your cylinder, right? So yeah, if you get these messages and you're sure that your code is running, that's how you troubleshoot that error, right? Just save your project, close it, and then open it again, right? Okay, so we are now going to introduce the last exercise for today, right? Which is on timers, right? So we'll be introducing timer on delay and timer off delay, right? So we want to delay our process before it begins, and also want to delay our process once it's done, right? So you want to delay advancement, and then you want to delay retraction, right? So now we're gonna introduce timers, right? So let me just go to the thingy, the presentation. Okay, so this is what we covered in this last exercise. So this connection was for end position sensing, right? So when you connect your start button with your sensor, your rear end sensor like that, this is for end position sensing. So in a test, should I say make sure that your cylinder senses the rear end position? There's the kind of connection I want to see, right? So just gonna go next. Then now we are coming to variables with timer. So if you can observe, all these timers, these six, so all our inputs and outputs are the ones that we defined ourselves, right? But the moment you include a timer, they get hard-coded by the program itself. So these ones you don't need to memorize or anything like that, right? Okay, you don't have to memorize, right? So now, let me see something. Okay. So now we're gonna build our ladder logic whereby we will be delaying advancement of the cylinder. So what will happen is once you press the start button, on the ladder logic will observe a timer counting down, and then once it has counted down, it will then advance the cylinder and retract it, right? So I'm gonna need you guys to also pay attention on this one, right? We're gonna go to our ladder logic, then we're gonna now introduce a network below, right? So a network is just the space where we build our ladder logic. So you're gonna click on the pink side there, you're gonna right click, and then you're gonna say insert network below, right? And then we're gonna go to, on the right side, there's a toolbox, and we're gonna put on our, gonna go under function block, we're gonna put on our, what's this? Our latching function block, and then we're gonna put on the timer. Then you're gonna connect like that. What? There's a recording, guys. You'll just follow on the recording. There's no more time, guys. And it's common ones that are complaining. It means you don't practice. No? Otherwise, it'd be like moving along with me, isn't it? Okay, anyway, so now we're gonna, so this setup is important on your timer. So you're gonna leave that. So once you see this, so this part here, it will be highlighted in purple, right? You're gonna click enter, and then you're gonna click enter again, right? And then here on your ET, you'll click there, and then you'll cancel it out like that, right? And then there on your PT, next to PT there, that's where we'll define the amount of time we want to like, this is where we define our the time of delay, right? So let us delay our cylinder advancement by 5 seconds. So how you code that is you press T hashtag and then 5S. So this is how you code your timer, right? So this means that your advancement will be delayed by 5 seconds, right? And then you can click anywhere there. And then now, so also on your latching function block, you'll just click there, and then you'll just click enter twice. You'll click. Okay, I think you, let me see. Okay, so it's we name this SR_0, right? Then you can click enter, and then you can click enter again. Right? So this is a set resetting relay for our timer, right? So we could say that this function block is responsible for setting and resetting our timer, right? Now, who is responsible for setting our timer? In this case, it's our center, it's our, what's this? Our I0, right? Our I0 is responsible for setting our timer, right? And then who's responsible for resetting is your sensor 2. Sensor 2. Now, remember, the normal state of sensor 2 is it's normally off, right? The nature it's false, it's off. So here we do not need to negate for sensor 2, right? What else am I missing? Okay, so if you were to negate, you would constantly be getting providing power to your reset of your function block. and that would not, your timer would not function properly, right? So you leave your S2 as a normal contact like that, right? Okay, and then we're gonna put a coil for our, so we'll have an output for our timer, right? And then we're gonna call it a memory 0, right? So this is the output of your timer, right? So your timer has an output as well, right? But remember what we said, this is gonna be counterintuitive in a way, right? Remember your output for your timer is the one that is, how can I put it? So your output for your timer, you're gonna need to substitute it with your with the contact that sets the timer, right? So in this regard, it is your I0. So in place of your I0, you're gonna put M0. Yes, but just know that this is still your start button, right? So you have your M0 there. Okay, there is an output. There's an output not defined here on our variables. Let me just check something. MO. So our memory, it's not defined there, right? So let me just let us also define our memory there. So just gonna press enter, M0, and then colon, and then O, and then semicolon, right? Then we have those outputs defined properly, right? Okay, so what should happen is once you press our start button, before the cylinder advances, it's gonna count down for 5 seconds and then it's gonna go forward, right? And then retract automatically, right? So let us simulate that, right? But before that, let us build our circuit, right? So we're gonna build. Then make sure once you build and you see this box not checked, just check it again and then build again. Okay, and then just build again for extra measure sake, right? Then you're gonna go to PLC program, and then you're gonna log in with download. Then click OK, and then you're gonna just close this. And then we need to observe something. So observe this time here in orange, right? So once we press our start, okay, let's press play here. So once we press our start button, the timer here should count down for 5 seconds. Before that, nothing will happen to your cylinder. Once the countdown is complete, the cylinder will advance and then it will retract, right? So let us just run that in FluidSim. Press play. Okay. So here we didn't change anything, right? So let me just, I just want to split the screen so that you can see in action everything. So for this case, you don't need to see the electrical circuit. You just need to observe your cylinder, right? So if I press the push button, you'll observe there on your right that the counter is counting up until 5 seconds. Once it has counted for 5 seconds, it'll advance and then it'll go back, right? And then we're just gonna do it again because that was cool, right? So you have your countdown there. And then once it reaches 5 seconds, it advances and then it goes back. Right? Then you have your timer on delay there, successfully programmed, right? Okay. All right. So I see we're out of time. So before we leave the venue, just make sure you save your file, this file in your thought space. Your FluidSim file and your codices file, right? But before you save, just make sure you stop everything. You log out and yeah, you log out and then you save. Because next week we'll just be doing 3 exercises. So we'll be doing timer off delay, meaning delaying retraction, and then we'll also be looking at how we can program a second that runs continuously, and then we'll also we'll do one question paper, and then I believe we'll be ready for your lab test too, right? So yeah, just save both your files, and then we'll carry on next week from where we left off today, right? So yeah, enjoy the rest of your day, guys.